After computing for the mean of a random variable, let us proceed to the computation of the variance and the standard deviation. For today, we are going to illustrate, calculate, and interpret the variance and standard deviation of a random variable. Also, we are going to solve problems involving variance and standard deviation of a probability distribution. Good morning, everyone. This is Teacher Jorel, and welcome to our online class. On the board, we have a probability distribution table. Random variable x is shown on the first column and its possible values. On the second column are the probabilities p of x and the respective probabilities of each possible values. On the third column are the products between p and p of x. When we add all the individual products, we get the mean of the probability distribution. And now I added one more column to our table, and I label it x squared. What we're going to do here is we are going to get the square of our x values. Let us begin. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared is 36. 7 squared is 49. And last, 8 squared is 64. Let us add another more column to our table, and I labeled it x squared times p of x. What we're going to do here is we will multiply our x squared column with p of x column. Let us begin. 4 times 1 over 16 is 1/4. 9 times 2 over 16 is 9 over 8. 16 times 3 over 16 is 3. 25 times 4 over 16 is 25 over 4. 36 times 3 over 16 is 27 over 4. 49 times 2 over 16 is 49 over 8. 64 times 1 over 16 is 4. After we multiply our p of x column and x squared column, we are going to add all our products. 1/4 plus 9/8 plus 3 plus 25 over 4 plus 27 over 4 plus 49 over 8 plus 4 equals 55 over 2. Or we can also write it in decimal, and that is 27.5. If we are going to subtract 27.5 with the square of our mean 5, that would be 27.5 minus the square of our mean 5. 27.5 minus 5 squared is equal to 2.5. 2.5 is our variance. Furthermore, if we take the square root of our variance, the result is 1.58. 1.58 is our standard deviation. Again, 5 is our mean. 2.5 is our variance. 1.58 is our standard deviation. Table number 2. After solving for the mean of this distribution, we arrive at an answer 3.1. 3.1 is the mean. Now, let us solve for the variance and the standard deviation. We are going to start with the column x squared. We are going to get the square of the x values. Let us begin. 1 squared is 1. 2 squared, 4. 3 squared is 9. 4 squared, 16. And 5 squared, 25. On our last column, we are going to multiply x squared and p of x. This is our x squared column, and we will multiply it with p of x column. Let us begin. 1 times 3/10 equals 3 over 10. 4 times 1/10 equals 2 over 5. 9 times 1 over 10 is 9 over 10. 16 times 2 over 10 is 16 over 5. 25 times 3 over 10 is 15 over 2. After we multiply p of x and our x squared, we are going to add all the products. 3 over 10 plus 2 over 5 plus 9 over 10 plus 16 over 5 plus 15 over 2 equals 123 over 10 or 12.3. To solve for the variance, we are going to subtract 12.3 to the square of our mean, 3.1. (12.3 minus 3.1 squared equals 2.69. 2.69 is our variance. And to solve for our standard deviation, we have to take the square root of our variance. The square root of 2.69 is equal to 1.64. 1.64 is our standard deviation. Again, 3.1 is our mean, 2.69 is our variance, and 1.64 is our standard deviation. Table number 3. Let us start by taking the square of our x values. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared is 36. Next, we are going to multiply x squared with p of x. 4 times 0.35 equals 1.4. 9 times 0.25, 1.5. 16 times 0.20, 3.2. 25 times 0.15, 3.75. 36 times 0.05, 1.8. And then, we are going to add all the products. 1.4 plus 1.5 plus 3.2 plus 3.75 plus 1.8 equals 1.65. To solve for our variance, we are going to subtract 11.65 to the square of our mean, 3.3. 11.65 minus 3.3 squared equals 0.76. 0.76 is our variance. And to solve for our standard deviation, we are going to take the square root of our variance. The square root of 0.76 is 0.87. 0.87 is our standard deviation. Again, our mean is 3.3, the variance is 0.76, and the standard deviation is 0.87. To summarize our formulas, mean, or E of x, is equal to the summation of x times p of x or f of x. The variance is equal to the summation of x squared times p of x minus the square of our mean. And finally, the standard deviation is the square root of our variance. Let us take a look on the results on our tables. Those tables come from an experiment and two problems. The first table is from an experiment that deals with two boxes A and B. The two tables comes from two problems. The first is the Masagana grocery store, and the second is about Dr. Santos operates on patients. Our table here shows us the mean, the variance, and the standard deviation. The mean of a distribution tells us the center or the average of the distribution. The standard deviation, on the other hand, tells us the dispersion or how well the scores are scattered from the mean. The bigger the standard deviation, the more scattered the scores are from the mean. The smaller the standard deviation, the closer the scores are from the mean. Our experiment on boxes A and B has a mean of 5 and a standard deviation of 1.58. This means that the middle score is on 5. The next score above and below 5 would be 1.58 away from 5. So we can say that the next score above 5 would be 6.58 and the next score below 5 would be 3.42. Our next problem is about the Masagana grocery store. If you remember, that problem asks us the average number of items that a customer buys when they visit the store. The mean of that problem is 3.1. It means that a customer buys an average of 3.1 items every time they visit, with a standard deviation of 1.64. What does it mean? The next score above the average 3.1 and below 3.1 would be 1.64 units away. So we can say that the next number of items that the customer buy would be 4.74 and the next item below the average would be 1.76. The next problem is about Dr. Santos and how many patients he can operate on a day on average. The mean of that problem is 3.3 with a standard deviation of 0.87. It means from 3.3 patients, the next score above 3.3 would be 4.17 patients and the next score below 3.3 is 2.43 patients.